So we are today going to talk about chi-squares. Chi-square is a inferential test to test whether there is a relationship between two variables. And it's ideal for testing two categorical variables. And we've already discussed how to test or see qualitatively the relationship between two variables in a contingency table. We discussed how the percentages would not be the same if there was a relationship, and today we're actually going to show how that actually translates into an actual statistical test where we're no longer saying, well, it seems like there might be a relationship, but we're not sure, to we know for sure there's a relationship based off of this statistical test, and we just need to explain how strong that relationship is. So the chi-square for contingency tables is a little bit of a longer lecture. We'll try to go through this step by step. I want to back up a little bit, though. I wanted to tell you, describe exactly some basic principles here. So how can we tell how likely it is that the relationship that we're actually seeing is genuine? And of course, the answer is we need to use a test of significance. It's not just a matter of like looking at a plot of a scatter plot and seeing dots and trying to draw a line and assuming that there's a relationship. Now we're actually going to apply an actual test of significance to get an actual numeric yes or no for the relationship between two variables. Essentially, it tells us the odds of concluding based on our sample that in the population our two variables are related. And a little bit of a refresher here. There are two hypotheses we need to consider in the scientific method, okay? One is the null hypothesis. The null hypothesis is a hypothesis that we all work with all the time. We don't even know it, but it's something we use all the time. And it's essentially a statement that in the population, the means of two or more groups are the same, or in the case of two variables in a contingency table, that in the population, the two variables are unrelated. So in other words, one variable is unrelated to another, okay? And it's often written like this, with an H for hypothesis and a 0 for null, or none, 0. The issue here is that when we use it every day, and because we're thinking to ourselves, we use it to make decisions. Does Johnny like me? I don't know. Does he like me? I don't think so, but we'll have to figure this out, right? So you do a test of significance. You don't even think about whether you do this or not, but you do. And you come up with an alternative. Well, it's possible. It's possible he likes me. Let's see. And then you send him an email or a text and you find out, right? So the null hypothesis is that Johnny does not like you. That is that there's zero relationship, no relationship between Johnny and you, right? And then the alternative is that there is a relationship. So using a more practical example, let's think about homelessness and education, okay? The null hypothesis would state there is no relationship. Null is no, right? Null is no. Let me repeat that. Null is no. So there's no relationship between homelessness and education. So if you're going to look at the study and you're going to try to decide whether there's a relationship between education and homelessness, you would state that your null hypothesis is that there's no relationship between the levels of education and your degree of homelessness or your likelihood of homelessness. The alternative hypothesis is a statement that in the population, the means of two or more groups are not the same, or in the case of two variables in a contingency table, that in the population, the two variables are not unrelated. In other words, they are related. So you write this with an H and a 1. The 1 is just not, it's just the way we write it. H is for hypothesis, and the 1 is the alternative hypothesis. So if the null hypothesis is that there is no relationship between homelessness and education, the alternative hypothesis is that there is a relationship between homelessness and education, or that homelessness and education are not unrelated, so they are related. So what we're doing in science is trying to show, we're either trying to disprove the null hypothesis and actually accept the alternative, or in other words, we're trying to show that the relationship we think actually is there is in fact there. So steps in significance testing. This is sort of basic science, but this is a background of essentially what we need to do in every statistical test we do. These are the steps we need to perform. So before you even look at your data, before you actually analyze your data, you need to decide on your null and your alternative hypotheses, okay? And your null hypothesis almost always, and particularly this class, it always will be, that there is no relationship between two variables, okay? So if the relationship, if the hypothesis you're looking at is, well, I think that there's probably a relationship between the amount of work a student works, number of hours a student works on a job outside of school and his GPA, then the null hypothesis would be that there's no relationship on the number of hours a student works and his GPA, okay? And the alternative would be that there is a relationship between the number of hours he works and his GPA. After your data are collected, you need to ensure that you have all the data necessary to perform the test. So that's number 2 here in your steps. Essentially, what that basically means for the chi-square is that you have a contingency table put together. That's all you need to make sure. If you have two variables that are put together in a contingency table, then you can perform a chi-square. The third step is to calculate the test statistic. And in Excel, I'll teach you in Excel how to do this, but I'm also going to teach you in this presentation or the next how to do it step by step by hand. But to calculate this test statistic, there are multiple steps to go through it, but it's basic math. You just have to know what the steps are. And then once you calculate the test statistic and you get an actual value at the end, so a chi-square score, then you compare that score to a table which has a bunch of critical values on it. And I'll talk about what those all are in a second too. And once you compare that score to the appropriate value at the 0.05 level of significance, you can decide whether you can accept or reject the null hypothesis. So 0.05, to refresh your memory, is the significance level at which the p-value, the probability level, the p-value, which is something we're always trying to get in a statistical test, is either less than 0.05 or it's greater than 0.05. If it's less than 0.05, then we have a significant finding. And it's sort of like the holy grail in all statistics. It's the backbone of everything you see published in the scientific literature. The p-value is less than 0.05. It's something which really makes or breaks a manuscript, makes or breaks someone being able to publish a study. If you have a p-value of 0.07, you have a harder time for sure to publish than if you have a p-value of less than 0.05. If your values are less than the appropriate critical value, then you cannot reject the null hypothesis. Okay? But if your values are equal to or greater than the appropriate critical value, you can reject the null hypothesis. And then you report the p-value, and you report the probability range if you have to, if you calculate by hand, and you report the findings. So all 9 of these steps are, there's a lot going on in these 9 steps, and we will go through each one of these steps as soon as we, in the next lecture.